Hello students, this is Deepak Pandey and this video lecture series of question asked in network analysis and synthesis in year 2018 and 19 we are going to discuss the questions of transient analysis. Okay, so the first question of transient analysis asked in 2018 and 19 was from section number B, question number 2D. तो इसमें यह पूछा गया था, ये हमें एक फिगर दिया गया है, इसमें बोला गया है in the circuit shown in figure the switch is moved from A to B at t equals to 0. So पहले हमें ये समझना है कि इस लाइन का मीन क्या है. इसमें हमें बोला गया है कि switch is moved from A to B. So it should be considered that switch was initially connected at A. तो कहाँ से कनेक्ट है? माइनस इनफाइनाइट टू t0 माइनस तक. ओके, so this should be the circuit for t is less than 0 condition. Under this condition steady state अगर कर चुकी होगी, so this inductor was at short circuit condition. Under steady state condition inductor behave like short circuit. So when switch was at A, first we are going to analyze it. What about the value of current here? Value of current is simply the voltage divided by the equivalent resistance 30 and 10 here. So it will be 30 plus 10. So the value will be equals to what? 0.5 amperes. Clear? 0.5 amperes. Now when the switch for t equals to 0, when the switch is moved फ्रॉम स्टेट ए टू स्टेट बी. अब ये ए से किधर पे आया है? बी पे आया है, तो सर्किट हमारा ऐसा बन जाएगा. सो हेयर द इनिशियल वैल्यू व्हेन स्विच मूव टू पॉइंट बी, द इनिशियल वैल्यू इज व्हाट? IL0 minus equals to this value 0.5 ampere. Under Laplace analysis, this initial value will be connect like this across the इंडक्टर के अक्रॉस ये IL0 या I0 माइनस जो है ये हमारे पास में इस तरीके से कनेक्ट हो जाएगी. ठीक है. फॉर एग्जाम्पल वी हैव कंसिडर दिस एज नोड नंबर ए, दिस एज नोड नंबर बी. नोड नंबर 1 एंड नोड नंबर 2 की आप बात कर रहे हो, देन व्हाट? एट नोड 1, एट नोड 1 KCL हम कंसीडर करते हैं. फॉर एग्जाम्पल यहाँ करंट, ऐसे करंट और इस करंट की बात कर रहे हैं. ठीक है, तो इधर आप KCL अप्लाई करो. देन व्हाट? इफ दिस पोटेंशियल इज V1, then as per KCL all the three currents, this current and this current, okay, the summation of all the three current must be equals to 0, क्योंकि सारी के सारी करंट एक ही डायरेक्शन पे हैं, मूविंग आउटसाइड with respect to the value of with respect to this node. So we can say that here V1 divided by this value 1 upon 0.25s, and it is equals to what? It is simply 4 divided by s. So it is V1 divided by 4 divided by s plus value of current is 0.5 divided by s plus this current value. If potential is V2, then it will be V1 minus V2 divided by the value of 4s, and it is equals to 0. This will be the equation number 1. And at node 2, so what about the node 2? This current, the same current through this, and for example this current. So at node 2, when we apply the KCL, then as per KCL it will be V1 minus V2 divided by 4s plus 0.5 divided by s will be equals to V2 divided by 10. It is equation number 2. Okay, equation number 2 is this. So from equation number, both the equations first and second, with proper manipulation. What about this? V1 divided by 4 by S plus 0.5 divided by S plus V1 minus V2 divided by 4S equals to 0. तो आप देखो this value and this value is equals to this one. So from this we can replace that SV1 divided by 4 plus V2 divided by 10 equals to 0. So from here we can calculate the value of V2 equals to minus of 2.5 S times of V1. What is the reason behind calculation of V2? देखिए हमें V के लिए एक्सप्रेशन को डिटरमाइन करना है वोल्टेज के लिए। ये जो वोल्टेज है वोल्टेज अक्रॉस कैपेसिटर वो सिंपली क्या है V1 है। सो वी हैव टू फाइंड द वैल्यू ऑफ V1 दैट विल डेफिनेटली द वैल्यू ऑफ V हियर। क्लियर? तो ये हमारे पास में कंडीशन है। अब इक्वेशन नंबर फॉर एग्जांपल दिस इज इक्वेशन नंबर 3। नाउ इक्वेशन नंबर 3 एंड इक्वेशन नंबर 1 को हम क्या करते हैं इक्वेट करते हैं। तो फ्रॉम equation number 1 and 3, equation number 1 is SV1 divided by 4 plus 0.5 divided by S plus V1 minus of V2 and V2 equals to this value, so plus 2.5 times of SV1 divided by 4S. Is that okay? So from here it is very simple. S square V1 plus 2.5 times of S V1 plus V1 divided by 4S equals to minus 0.5 divided by S. Okay, again, so from this value V1 equals to what? V1 equals to minus 0.5 multiplied by 4 divided by S square plus 2S plus 1. Okay, what is my V1? V1 should also be the term of S. ठीक है, तो इधर से कितना आ जाएगा? This will be minus of S square plus 2.5 S plus 1 and it is simply minus 2 divided by S plus 0.5 and S plus, yeah. Now by partial fraction. So the by partial fraction we can separate as 2 divided by S plus 0.5 S plus 2 equals to A divided by S plus 0.5 plus B divided by S plus 2. On partial fraction, on solving it, we will get the result A as minus of 1.33 and B as 1.33. So V1S is equals to what? V1S is minus 1.33 divided by S plus half. 1 by 0.5 is 1.2. 133, just a minute. 1.33, the value of B divided by S plus 2. Now inverse Laplace, we will get V1t equals to what? Minus 1.33 e raised to the power minus t by 2 and it will be 1.33 e raised to the power minus 2t and this one is VCT, the desired value. So it will be equals to what? 1.33 minus e raised to the power minus t by 2 plus e raised to the power minus 2t volts. So our desired answer is this. Okay. Now moving on the next question. And this question, for RC series circuit, switch is closed at t equals to 0. Find out the current expression, also draw is transient curve. ठीक है, तो इसमें हमें क्या करना है, we have to analyze a RC series circuit. Okay, so a RC series circuit be like this. तो ये हमारे पास में एक RC series circuit दिया गया है. Okay, now at initial condition, अगर first thing is at initially what, at t equals to 0 we are talking about t equals to 0. t equals to 0 means सर्किट ऐसा कंसीडर किया गया है. तो जब भी सर्किट ऐसा कंसीडर किया गया है, then initially capacitor behave like what, capacitor behave like a short circuit. Capacitor behave like short circuit. Since capacitor behave like short circuit, then what about the value of current? Initial current will be equals to what? Simply V divided by the value of R. Initial current in this particular condition will be V divided by R. Okay, now apply KVL. Now apply KVL for t is greater than 0 value. So for t is greater than 0 value, the KVL is V equals to Ri plus 1 upon C integration it dt. Okay, on differentiating, we will get, what about this DC source? So we will get 0 equals to or the derivative of R into I, it is R di by dt. The derivative of integration I dt will be I, and the derivative of V equals to 0, or di by dt plus I upon RC इक्वल्स टू 0. ठीक है, तो ये हमारे पास में कंडीशन है. इक्वेशन नंबर फर्स्ट, फॉर एग्जांपल दिस इज ए फर्स्ट ऑर्डर होमोजेनियस इक्वेशन, and the solution of first order homogeneous equation will be what? Yt equals to k. फर्स्ट ऑर्डर होमोजेनियस सोल्यूशन अगर इक्वेशन हमारे पास में है तो उसका सोल्यूशन होता है yt equals to k e raised to the power minus at, where at equals to what? at equals to this value, और it is the solution है. सिंपली अगर आप बात करो तो at यहाँ पे कितनी वैल्यू हो जाएगी? a is 1 upon rc here. Okay, in this particular situation. Clear now? So the solution of general solution of equation number 1 will be what? It will be it equals to k e raised to the power minus t upon rc. Now for t equals to 0, when t equals to 0 we are talking about I0, and I0 is equals to V divided by the value of R. So we will get V by R as the value of K. Okay, so the expression, for current will be what? It equals to V divided by R e raised to the power minus t upon rc. Is that okay? So the expression for current is V divided by a minus T upon RC value. Now here, for T equals to 0, the value of current equals to V by R, and for T equals to infinite, the value of current will be 0. So with exponential decay, current may be read draw as like this. Current profile कैसा होगा, इस तरीके से बनेगा, where for T equals to RC, the value of current equals to what? It is equals to 0.36 V divided by R, and this value is known as what? This value is known as time constant of RC circuit. So the time constant of RC circuit is what? In terms of current, when the value of current becomes 0.36 or 36% of its initial value, then the time is known as time constant and represented by tau. Okay, so these were the two questions were asked in 18 and 19 question paper. So stay tuned for